The graph of the function can be often used to determine intervals or values of x for which the f of x is positive or negative or greater or equal 0 or less or equal 0. We have to remember that the graph of a function is the set of points x and y, where y is equal f of x. So if I want to find the values of x for which f of x or y is positive, I will be looking for the points on the graph for which y coordinate is positive. Those points, the y coordinate is positive, are above the x-axis. Below x-axis are the points where the y is negative. On the x-axis are the points where the y coordinate is 0. So if I want to find the intervals, if I have a graph of the function and I want to find the intervals for which f of x is positive, for example, I will have to identify the parts of the graph that have y coordinate positive and figure out what values of x make this part of the graph. So, for example, in our case, I'm looking for the solution of the inequality f of x is greater than 0. So I'm looking on the graph and I'm looking for the parts of the graph that have f of x or y greater than 0 and therefore above the x-axis. And those parts of the graph are right here. The whole part here is above x-axis and this part is above the x-axis. Now again, I'm looking for the parts where f of x is greater than 0, so I cannot include the points on the x-axis because those points have y coordinate 0. So once we identify the parts of the graph for which y is positive, we'll just have to figure out what values of x produce that part of the graph. So here clearly the first part of the graph starts when x is equal -3, then ends when x is equal 0. So f of x is greater than 0 if x is in the first part, again as we said, from -3 to 0. None of the endpoints is included because we want values of y to be strictly positive. And then there is another part of that graph that starts at 2 and continues indefinitely, so we'll have interval from 2 to plus infinity, and because we have two intervals, we'll put the union sign.